evening and welcome to Tinkering with Edkelar. Well, this week I wanted to have a vintage tube radio project ready, but there have been complications. So to keep the pace going, I present you with a smaller piece of lab equipment. This little box here is a pulse generator made by Philips, model number PM5705. It was made around 1974, so the inner workings are an interesting mix of TTL and analog tech. Let's have a peek. When it arrived, it was a bit dirty and had lots of stickers attached all over. So let's dig in. Classic construction. One PCB, a few components around some TTL ICs, and not much more. The handle doubles as a tilting stand. It comes off with the screws on the side. The switches are mounted in the middle and have extensions. The power switch is in a shielded section in the rear. The button is extended right across the entire case. Oh, and there's a zip tie holding it in place. I wonder if that is original. The power indicator lamp is mounted within a light pipe. Removing the dials was a bit annoying. I tried pretty much every socket I have, but none would fit. I had to use my needle nose pliers to undo the nuts and get them off. Funny fact, the baseline offset is a potentiometer with an associated switch, so it feels like turning on or off the offset. But that switch is actually unused, just a dummy for the user experience of the click. The PCB is held in place with plastic clips. They seem to have suffered a bit in transport and most of them are busted. Time for some OpenSCAD and 3D printing. The transformer is wired up for 220 volts already. That's good. Philips saved on the selection switch and included a label instead. Now to the PCB. It is single-sided, that makes soldering a bit easier. I'm doing a recapping here. These old Philips caps are a bit on the maybe side, and there's not many of them. The output stage for the signal is made up of 2 transistors that are mounted inside a heatsink, and for some reason that heatsink is draped over 3 capacitors, 2 ceramics and 1 electrolytic. How weird! The handle made a squeaking noise, but it seems to be glued shut. I discovered that one end of it is coming apart, so a bit of careful prying later I have it apart and can add a bit of grease after a good wipe down and before gluing it shut again. I also removed all the socketed components, that is the transistors and 2 of the ICs, to add some contact cleaner. I also removed the external potentiometers and took them apart. They use 4 screws, but the wiper is pressed into the plastic center. Well, at least I can lubricate the shaft and add a spritz of contact cleaner. The wafer switches for the range selection are tarnished badly, giving them a good clean and also lubricating the spring-loaded cam mechanism. Attaching the front plate again and realizing that the key on both wafer switches are 180 degrees out. I put on the cover plate upside down. The switch is in sync, but it's just the key that is upside down. Opening it up, flipping it over and mounting it again. I only had one matching capacitor in axial style, the others are replaced with radial ones, bent into proper shape. Only the one underneath the heatsink was problematic and needed a bit of an extension to fit. Whoops! That IC certainly needs some scrubbing. Uh-oh, the power indicator lamp is suffering from a broken leg. I'll just replace it with a yellow LED. Like with the most recent logic analyzer, the PCB already has a dropper resistor for the lamp, so I just replaced those with a better value. Connecting the coaxial lines for the BNC connectors again. These are soldered in a weird way. There are soldering pins for the ground and the hot wire next to each other. The hot wire is passed through the hole in the ground one and connected to its own pin. Then the shield is soldered to the grounding pin. Pretty easy and effective to solder, but a nightmare to desolder. The main switch is hidden in that little compartment for a reason. It is a completely open design, literally. This makes it quite a bit easier to clean the contacts though. The remade PCB clips are a nice fit on the PCB side, but the rail in the frame is a bit snug. So stop! Hammer time! putting the front panel back into the bezel. It clips right in. Now, power on time! I want to check the power supply section first. The regulation section has two jumpers in line. I removed them so I can check on the voltages without worrying too much about the downstream components. But there is 0 after the main pass transistor. It has 35 volts input alright, and about 0.4 volts on the base, but 0 volts output. Darn! I suspect the regulator IC might be toast. A bit of measuring and optical inspection later reveals another oopsie. I replaced the resistors for the power LED. Well, the solder mask of a trace right next to one of those pads was lacking in quality, so I managed to short these two traces together ever so slightly. And after removing that solder spill, I got voltage. Both the 20 odd volts for the output stage and the 5 volts for the TTL chips are in spec. Another slight oopsie. I used the flathead screw for the grounding wire, since I recalled that all of the heatsink related screws were flatheads. But I was wrong. The grounding wires are held in place with a different one. The flathead is now missing for the grounding point on the side of the case. After a bit of fiddling around, I managed to put those two screws in the right position. And after flipping the rear around right side up again, the case is now pretty much done. Now to the fun part. Adjusting all the trimmers. I follow the adjustment guide and get a reasonably well-behaved set of controls. Note that the numbers on the dials probably never going to align perfectly with all the steps, but they are well within the tolerance that I'd expect from an analog device. Were there any issues? Well, 1. The trigger or gate input. You can set up the duration control to react to an external input on either positive or negative going edge. The positive one worked fine, so a few nanoseconds after the trigger pulse, the device delivered the requested pulse on the outputs. But switching to negative didn't work as expected. You can see here that the negative trigger was happening when the input was still at a high level. Either that or the trigger predicted the drop. Strange. Turns out that while the trigger input should work with about 1 volt input signals, it actually only almost does. It takes about 2.2 volts to make sure that the input section does the correct thing and the inverted trigger signal is actually at full length. There seems to be some capacitor charging going on, and the Schmitt trigger of the logic gates narrows the pulse, which leads to the negative edge being way too soon. And now to button up the case. And that's it. A nice pulse generator with TTL and analog level outputs that can do up to 10 MHz or single shot pulses. I'm sure there's better ones out there, yes, but I like that old school Philips design. My lab power supply still works perfectly. I hope you enjoyed this little bit of more uncommon test gear. As for the tube radio project, it may or may not be the next video. That depends on some solutions. I have some other nifty devices in the queue, so something will be done. See you next time! Also lubricating the spring-loaded spring-loaded camshaft. The springs in the spring have sprung.